Assalamu alaikum. I am Mohamed Madan, master in Ahlia University. I would like to show you my dissertation. I will be talking about email spam filtering using artificial neural network. This is my agenda. I'll talk about what is email, what is spam, and previous research papers, what they wrote, and what is the problem statements, my objectives, research design, the proposed email spam system, and the results conducted through my experiments, conclusion, and future work. Everybody has an email, whether it is personal or a business. So spammers are utilizing, since email is free, spammers are utilizing the email to send unwanted emails, bulky, to the users. So there is a potential security threat to the users where spammers can send malwares, viruses, and phishing. On daily basis, 80 billion spam emails are sent, and 40,000 users are replying to the spam emails. And this is a big risk. Symantec is a security company. They released a report on recently, 2019. It indicates that spam takes 55% of the email received on 2018. With the reference to 104 research papers from the period of 2013 to 2019, we discovered that there are people who still used access rules or blocking IP or searching for a specific word to block the email. So researchers are trying to improve the techniques used by machine learning. Through the research, I discovered that there are researchers who filter the email only through the header of the email or only the body of the email. So in my research, I have included both of them. Machine learning, there are a lot of machine learning techniques and processes to filter the email spam. For example, in feature extraction, there is TF-IDF, term frequency, and in feature selection, we have, for example, chi-square, we have mutual information, and information gain. With regards to the accuracy results achieved by other researchers, it's obvious that the accuracy is not very high. So we are searching for an efficient technique to filter the email spam. Researchers used classification algorithms like neural network feed-forward approach, but still the error rate is still high. Neural network backpropagation is implemented, but the accuracy and performance achieved is not satisfied and needs to be improved. What we will do, we will conduct a research on backpropagation neural network to improve the accuracy detection of email spam. My objectives is to analyze and prepare the data set and make data appropriate for the classifier. To propose the email spam filtering using backpropagation neural network classifier. To analyze and evaluate the classifier for the proposed spam filtering system and compare it with other classifiers like simple vector machine, and naive Bayes classifier. And the results, what we will get from neural network will be validated with cross-validation. In addition to, we will use the grid search for adjusting the parameters of the neural network. There are a lot of, maybe I counted maybe 22 or 21 data sets for email spam filtering. So choosing the data set is important. The data set can contain only the body or the body and some data in the header side. So this is one of the important things in email spam as experiment. Pre-processing, we did a pre-processing for the data sets by 9 steps. We also did a cross-validation for the data set to make sure that the overfitting problem is not occurred in our research. And then we have extracted the features. It was 26,000 something, and we minimized it to 4,000 features only by using mutual information and feature selection. We applied neural network backpropagation, adjust the best parameter through grid search, and then for the future, we don't need to reapply or retrain the classifier and again for our testing, or can be used for the production. We have used classifier model. After using classifier model, we imported 6 data sets to make sure that the system is well implemented. And then we got the evaluation matrix. That means accuracy, recall, precision, and F1 score. This is a sample of what our research design. The data set we have selected Enron, it's distributed among 2 phases, training and testing phase. In the training phase, we use supervised neural network. So there will be a label over there, and we did a pre-processing, feature extraction, feature selection, and then we used we got that, we implemented into classifier as a training. In the testing, we did the same. We have created a classifier model and to classifier model to protect us whether the email is ham or spam. And then we noted down the performance evaluation for each classifier. The system is implemented through Python version 3.6. The dataset has been selected was Enron dataset, implemented on 1, means we did our experiment with 1 dataset. And then tested for 5 means we have run the same system with the same parameters for 5 datasets to make sure that the system is well implemented as accuracy or for the evaluation criteria. The feature we did pre-processing in 9 steps because the emails has, for example, HTML code, HTML tags, it has stop words, unneeded words, for example, going in, at, where, in. These will not give a meaning, so it has been removed. In the feature selection, we experiment 3 algorithms, a TF-IDF, bag of words, Enneagram. And in feature selection, we have experiment 2, chi-squared with mutual information. We have implemented neural network backpropagation with the parameters, with the different parameters, and we'll come to it later. The data set is distributed on 2 subsets or sets. Training will be 70% for the classifiers, and testing will be 30%. Cross-validation has been implemented with 5 folds, with the grid search combined with the grid search. classifier model has been implemented for the future use. We analyze the result and compare it with SVM and NP. We did 9 experiments, 3 in a pre-processing stage, 3 in feature extraction and selection stage, and 2 in the classifiers algorithms. I have put only maybe 4. I will show only 3 here or 4, and the remaining will be at the end of the slides. I can show you. Support. We have developed the Python code that's compared with NLTK tools, and the result is the Python code has more accuracy than the NLTK tool, because the number of, if you look, the number of supports at NLTK is 179 words, where the Python code has 679 words codes. The features after removing these stop words is 26,915. The accuracy has been removed. The accuracy of back propagation in neural network is 98.84, which is far away better than naive Bayes or SVM. Now, feature selection and extraction. What we did in this scenario, we compared chi-square with TF-IDF and chi-square with bag of words. This indicates that TF-IDF is better than bag of words. We compared mutual information with TF-IDF, and we discovered that mutual information is better than bag of words, as well as better than TF-IDF. If we look here into the red color circle, this indicates that the mutual information used with TF-IDF is better than chi-square with TF-IDF. Okay, now after we noticed that mutual information is better than mutual information with TF-IDF, better than bag of words or chi-square with bag of words, we implemented Ngram. Here, using TF-IDF will Ngram will give better accuracy with less features. For example, now TF-IDF will Ngram will have 26,915 features, and the accuracy reached up to 98.6. Where if we use Telegram, it will be 98.1. But the number of features is much higher than others. This will consume a time and a space. To make sure that the classifier is achieving what we want, we have applied the 5 or 6 data sets, and this is the results. Neural network backpropagation, I have implemented in 2 ways, without or with cross-validation. If you notice that the result of neural network backpropagation is almost, it's more accurate than neural network backpropagation, and if you see difference, it's a little bit compared with the others. Now, a neural network backpropagation achieved better than the other classifiers, I mean naive Bayes and simple vector machine. This indicates, this is where from the system where the data set is distributed among training and testing sets with the cross-validation. And right on the top, the classifier is searching for the best parameters using a grid search. With the top one, the down screenshot, it will show the accuracy result of 98.6. Conclusion, pre-processing can improve the performance of other classifiers. Means not only the backpropagation neural network. Using mutual information with TF-IDF gives better results for email spam filtering. The result of neural network backpropagation is the best results among other classifiers. The accuracy result achieved by neural network is 98.6 using a cross-validation with the grid search. Future work. We will consider the image recognition and image malicious codes. Support of other languages like Arabic, French, and Chinese. Also, time complexity of the grid search algorithm to reduce the time computation. Thank you.